Hello everybody, this is the last video on Unit 5, video number 6. We will see the last part of nucleophilic attack to coordinated ligands. That is, nucleophilic addition to CO to carbonyl, as well as some examples of electrophilic attack on coordinated ligands. The carbonyl ligand is very sensitive to nucleophilic attack when coordinated to metal sites of low pi basicity. On such a site, the carbonyl carbon is positively charged because the carbonyl to metal donation is not compensated by the metal carbonyl back donation, and the carbonyl pi antibonding orbitals are open to attack by the nucleophile. Remember, the nucleophilic addition is favored when the metal is in a high oxidation state, when the other ligands are not good donors, or if the complex bears a positive charge. The nucleophilic attack converts the metal carbonyls to their corresponding anionic acyls. The net negative charge now makes the acyl liable to electrophilic addition, for example, methylation, producing the Fischer-Carbene complex. Alkyl lithium reagents convert a large part of metal carbonyls into the corresponding anionic acyl complexes. This is an example in which a Fischer-Carbene is obtained. Starting with the nucleophilic attack to a coordinated carbonyl by phenyl lithium to afford the intermediate acyl anion, which is susceptible to undergo electrophilic methylation. Note here that the methylating agent used in this reaction is trimethyloxonium tetrafluoroborate, known as Mirvine salt, that it is a strong methylating agent. The nucleophilic addition of OH- to the carbon in carbonyl gives rise to an anionic unstable metallocarboxylic acid intermediate, which decomposes, presumably by beta elimination, to give CO2 and the metal hydride carbonyl metallate. Nucleophilic oxygen in trialkylamine N oxide is capable of attacking the carbonyl carbon atom to give a species that can break down to CO2, triethylamine, and the corresponding 16-electron metal fragment. Note how the cis-desubstituted product is obtained selectively, because a carbonyl ligand trans to another carbonyl has less back donation from the metal, and hence is more activated toward nucleophilic attack at carbon than is the carbonyl trans to the weak pi-acidic triphenylphosphine. Unfortunately, the amine formed can sometimes coordinate to the metal. Note also that successive carbonyls become harder and harder to remove as the back bonding to the remaining carbonyl groups increases, and so we are usually unable to remove more than one carbonyl group using this trialkylamine N oxide. Once again, remember, trialkylamine N oxide are very good reagents to substitute one and only one carbonyl ligand. Remember that there are two possible modes of nucleophilic or electrophilic attack. the addition mode, and the abstraction mode. We have already seen the addition mode, and we'll talk now about the abstraction mode. In the abstraction mode, the reagent detaches a fragment from the ligand or even the entire ligand, in which case the modified reagent leaves the coordination sphere of the metal. Often, reaction with an electrophile generates a positive charge on the complex and prepares it for subsequent attack by a nucleophile. Let's start, for example, with the electrophilic abstraction of hydride. The trityl cation in the form of the tetrafluoroborate salt is the classic reagent to abstract, for instance, a hydride in beta position with respect to the metal. Note that the starting iron complex has 18 electrons, no vacant position, and therefore beta elimination would not take place without the corresponding reagent. In the second example, we can see that sometimes this abstraction can be made in alpha, giving rise to a metal alkylidine or Schrock carbene. Note that Schrock carbenes are dianionic 2-electron donor ligands. Other example is the electrophilic abstraction of hydride from the neutral ligand cycloheptatriene, in which a positive charge is generated by taking the hydride, that is, by taking the hydrogen together with the pair of electrons. The cycloheptatrienyl ligand obtained is a positive ligand called tropylium cation. Similarly, it is possible to abstract other inorganic anions, such as fluorido or hydroxide, using the trityl cation. The compound obtained by hydroxide abstraction from hydroxymethylferrocene can be viewed as an 18-electron hexahaptofulvene complex rather than as a genuine carbocation. The bending angle of the exocyclic double bond towards iron is 21 degrees, which clearly shows that this double bond is coordinated to iron. Finally, the abstraction of a methyl carbanion can also be effected using the trityl cation. With this video, we have finished Unit 5, Reactions of Transition Metal Organometallic Compounds. Thank you very much for your attention.